Okay, so for today's lesson, we are going to be learning about the quotient rule. Okay, so this will be one of the last rules that we talk about. So yeah, it's a little bit, it's not as easy as the chain rule or the product rule. I think the most difficult part with this rule itself is just factoring and simplifying our answers. So we just have to be a little bit careful about that. Okay, but other than that, we're pretty much like still finding a u, still finding a v, derivative of u, derivative of v, etc. Okay, so for functions like y is equal to 3x minus 1 divided by x minus 2, this can be differentiated by writing it with a negative exponent. So y is equal to 3x minus 1 bracket x minus 2 to the exponent negative 1. So we could do that using the product rule. However, sometimes it's going to be a lot easier for us to actually just use this quotient rule. And you guys do need to know the quotient rule. Okay, so if there's a question that says differentiate using the quotient rule, differentiate using the quotient rule. Oh, one too many. Okay, so the quotient rule is if y is equal to u over v, where u and v are both differentiable functions, and v does not equal 0 for the value of x, for which you're finding the derivative of, then, so the derivative of y with respect to x is equal to v multiplied by the derivative of u with respect to x, subtract u multiplied by the derivative of v with respect to x, divided by v squared. Okay, in this one, the order is v important. Okay, because we are subtracting, so we just have to be conscientious of that. Okay, this is, you can also find this proof on page 66. And this one is derived from the power rule. Okay, so the derivative of y with respect to x for the quotient rule is v multiplied by the derivative of u with respect to x minus u multiplied the derivative of v with respect to x divided by v squared. Or in a little bit of shorter notation, we have v multiplied by u prime minus u multiplied by v prime over v squared. Okay, those are pretty much the same thing, just in different notations. Okay, yeah, so that is the quotient rule. So let's get on with it. Okay, so differentiate each of the following, write answers factored as fully as possible. Okay, so in this case, the numerator, well, in all cases, u is going to be the numerator. So u is equal to 3x minus 2. And v is going to be the denominator, which is x squared plus 1. So like we've been doing, let's just find the derivative of these right away. So u prime is just going to equal 3, and v prime is going to equal 2x. Okay, as per the power, or the quotient rule rather, so the derivative of y with respect to x is equal to v times u prime subtract u times v prime over v squared. Okay, so now we can just substitute these in. So v is x squared plus 1, u prime is 3, subtract u, which is 3x minus 2, multiplied by v prime, which is 2x, divided by v squared, so 3x minus 2 squared. Okay, at this point, we can simplify, so we can distribute the 3 into these brackets, and same with this 2x. Okay, so we will get, yep.
Is it v or u squared on the bottom?
That is a v squared.
Okay.
Yeah, sorry. I know I can't really be as accurate as I would like with this pen. So I'm sorry.
But then would it be x squared plus 1 squared or plus 1 all squared on the bottom?
3x minus 2 squared.
Is that u or v?
V. Oh, so let me make sure that I have the right v in there, hey? Thank you, Aaron.
Okay, sorry. I was like, I'm not sure if I have the wrong letters.
No. You are totally right. Thank you. Okay, so let's put down the right numbers. All right, variables. So v is x squared plus 1. U prime is 3 minus u is 3x minus 2. And v prime is 2x divided by v squared. So let's make sure I'm looking at the right one. I confuse myself with the v's and the u's, so I understand your confusion. Thank you for pointing that out. So x squared plus 1 squared. So v squared goes on the bottom. Very good. Okay, so like we were doing before, we found my mistake. We'll distribute these in. So this will equal 3x squared plus 3 minus 6x squared minus 4x. We need to be careful. So if we do brackets here, okay, so if we distribute this negative in there now, we'll get 3x squared plus 3 minus 6x squared plus 4x divided by x squared plus 1 squared. And we can clean this up a little bit. We have a negative 6x squared and a positive 3x squared. So this will equal negative 3x squared plus 4x plus 3 divided by x squared plus 1 squared. Okay, so just a note here. So we always factor if possible. Okay, in this case, we cannot factor the numerator, so we don't want to use the quadratic formula for that, okay? So that's okay. So always factor and simplify as much as we can. Okay? Cool. Okay, number B, letter B. Okay, so y is equal to 5x plus 3 divided by x minus 2. So the u is going to be our numerator. So u is equal to 5x plus 3. And v is equal to x minus 2. So u prime is equal to just 5. And v prime is equal to just x. Okay, so as per the quotient rule, derivative of y with respect to x is equal to v times u prime minus u times v prime over v squared.
Jones,
Yeah.
for v, isn't v prime just 1? Because if you put the
yeah, it sure is. Thank you.
yeah, for sure. Sorry, I just didn't know if I was like doing it wrong the whole time.
No. You are absolutely right. A couple mistakes for me today. Thank you for pointing them out. Okay, so now we'll just substitute in our values. So v is x minus 2, u prime is 5. Subtract u, 5x plus 3, multiplied by v prime, which is just 1, absolutely. And then divided by v squared, which is x minus 2 squared. Okay, so we can distribute the 5 into this bracket, and same with the 1, but that won't change anything. So this will give us 5x minus 10 minus 5x plus 3 over x minus 2 squared. If we distribute that negative inside of the brackets, we will get 5x minus 10 minus 5x plus, minus 3 divided by x minus 2 squared. We have a 5x and a negative 5x, so those will cancel. And negative 10 subtract 3 is equal to negative 13. And that's as much as we can do for that one. Any questions so far? Perfect. All right. So we can combine the product rule with the chain rule. So here we are going to kind of leave the quotient rule behind for a second. Okay. So that's okay. So here's our function, y is equal to 2x minus 1 to the 10 multiplied by x minus 1 to the third. So we will let u equal 2x minus 1 to the 10. And v will equal x minus 1 to the third. Okay, u prime is equal to 10 multiplied by 2x minus 1. This is just the 9 here, or sorry, the chain rule. And then remember our shortcut for the product rule, we're also going to multiply by the derivative of what is inside the bracket. So that is going to be 2. And then for v prime, we're going to put the 3 out front, x minus 1, subtract 1 from the exponent, and then multiply it by the derivative of what is inside the bracket, which is 1. We can simplify u prime a little bit by multiplying the whole numbers. So 10 multiplied by 2 is 20, 2x minus 1 to the 9, and v prime will be the same because 3 times 1 is still 3. Okay, so now that we have u prime and v prime, we can solve this using the product rule. So the product rule is u times v prime plus v times u prime. So now we can just substitute those in. So u is 2x minus 1 to the 10. V prime is 3x minus 1 squared plus v, which is x minus 1 to the third multiplied by u prime, which is 20 bracket 2x minus 1 to the 9. All right, so how can we clean this up a little bit? So let's put our constants out in front first. So we'll have 3, 2x minus 1 to the 10, x minus 1 to the 2, plus 20 multiplied by x minus 1 to the 3, x minus 1 to the 3rd, there it is, and then multiplied by 20 to x minus 1 to the 9. Sorry, that 20 should not be there because we already put it out in front. Okay, so it should look like 3 multiplied by 2x minus 1 to the 10 multiplied by x minus 1 to the 2 plus 20 multiplied by 2x1 to the 9 multiplied by x minus 1 to the 3. So at this point, we need to ask ourselves, what is common to both terms? And when we mean both terms, we mean on like left and right of the plus sign. So let's take a look at that for a second. Okay, so we will have 2x minus 1 to the 9 is common in both. And we also have x minus 1 to the squared that are common in both. Okay, so if we look on the right side of the screen here, we have x minus 1 to the right side of the plus sign, we have x minus 1 to the 3rd. And on the left, we have x minus 1 to the 2nd. We're going to be factoring out the lowest exponent. Okay, so let's rewrite this as factored terms. So y prime is equal to, so we factored out 2x minus 1 to the 9. And we also factored out x minus 1 to the 2. And if we do that, we will be left with a 3. On the left side of the plus sign, we'll be left with a 3 and also 2x minus 1. No exponents, right? Because if we took out 9, 2x minus 1 to the power of 9, there will only be 1 remaining there. Okay, we still have the 20 remaining. And because we took out 2 x minus 1s to the squared, we will have 1 remaining. So these square brackets here, we can simplify by distributing the coefficients into the brackets. So that will give us 6x minus 3 plus 20x minus 20. Okay. This bracket in here, oops, we could simplify that. We have a 6x and a 20x, and we also have a -3 and a -20. So that will give us 26x minus 23. Okay. Questions? Perfect. Okay, so this next one, we have y is equal to x minus 3 to the -2 multiplied by x plus 1. Okay, so we will let u equal x minus 3 to the -2. And v will be x plus 1. So u prime will be -2 x minus 3 -3, because we're subtracting 1 from the exponent, and then we're going to multiply that by the derivative of what is inside the brackets, so just 1 here. And this guy here, the derivative of v would just be 1. And sorry, I should have simplified this before I went. 1 times -2 is just -2. Okay, so now that we have u prime and v prime, we can use the product rule again. So y prime is equal to u times v prime plus v times u prime. So u x minus 3 to the -2 multiplied by v prime, which is just 1, plus v, which is x minus 3 to the -2. Let's put in actually v though, and not u. Sorry. So y prime. And u prime is -2, x minus 3 to the -3. Okay, so like we did earlier, we can simplify this a little bit. So 1 multiplied by x minus 3 will just be 1. And then we'll take the -2 out front. Okay, so now we need to look at this and ask, what is common? So what is common in both? So, and remember, we're factoring out the lowest exponent. So what is common in both? Well, the x minus 3 is common in both. And what is our lowest exponent? -3 is smaller than -2. So we will factor out the -3. Okay, so this step kind of took me a little bit to wrap my brain around, but that's okay. So when we're factoring out, we're going to be subtracting, right? So we have x minus 3, and it started out with -2, right? but because we're factoring out -3, we're subtracting -3 from that. Okay. And then over here on the other side of that, we'll have -2 is going to stay, and also x plus 1. So minus 2x plus 1. Okay. So let's rewrite this again. So still have x minus 3 to the -3 out front. So x minus 3 to the exponent -2 minus -3. So we're adding 3 to -2. So that will just be x minus 3 to the power of 1. Okay. And then over here, if we distribute that in there, we'll have -2x plus 2. I could have distributed the -2 in there last time, but that's okay. We'll do that now. So y prime is equal to x minus 3, -3, bracket x minus 3, subtract 2x, subtract 2. Okay, we have -2x and a positive x, and -3 and a -2, so we can simplify that. So x minus 2x will give us -x, and -3 minus 2 will give us -5. Okay, and when we present our final answers, we don't like doing that with positive or negative exponents rather, so we can rewrite this as y prime is equal to -x minus 5 over x minus 3 to the 3. Okay. All right. 2 to go. Okay, so in this question here, remember that anything under the square root will have an exponent of 1/2. So like we've been doing, let's write our u is equal to x minus 1, and our v will be x plus 3 to the exponent 1/2. So take the derivative of both. So u prime is just 1, and v prime is equal to 1/2 x plus 3. 1/2 subtract 1 will give us -1/2, multiplied by the derivative of what is inside the brackets. So multiplied by 1. So v prime is equal to 1/2 x plus 3 to the exponent -1/2. Okay, so now that we have that, back to the product rule. So y prime is equal to u times v prime plus v times u prime. U x minus 1. V prime is 1/2 x plus 3 to the exponent -1/2 plus v x plus 3 to 1/2 multiplied by u prime, which is just 1. So like we've been doing, let's take the whole coefficients out. And then we'll just be left with x plus 3 to 1 over 2 right there, because we just multiplied the 1 in there. Everything will stay the same. Okay, so again, what is common? So in both terms, the common term is x plus 3. And remember, we want to factor out the lowest exponent. So it'll be negative 1 over 2. Okay, so we'll still have, oh, I missed one important part as well. When we are taking out the greatest common factor, we want to take out any fractional coefficients as well, okay? Sorry, I missed that step. So I'm just gonna make a note here. So we factor out the lowest exponent and any fractional coefficients. Okay, so I actually also wanted to put in 1 over 2 up here. And that's actually beside the y prime. I know it doesn't look like it, but just trust me. Okay, so now that we have taken out 1/2 and x plus 3 to the negative 1/2, we will have x minus 1 here. Plus, so if we take out 1/2 of that coefficient, we will have 2 out in front. So if you don't trust me here, you can just redistribute it back in to the factor and it will work out. So I'll have 2x plus 3. And because we had a 1/2 to begin with, but we are subtracting the negative 1/2. Sorry, that is a minus x minus 1. So plus 2x plus 3. And then 1/2 subtract negative 1/2. So we're adding a half. That'll just be to the power of 1 there. Okay. So at this point here, we can distribute this 2 inside. So we'll just have x minus 1 plus 2x plus 6, which we could simplify, right? So x and 2x will give us 3x. Negative 1 plus 6 will give us plus 5. And I know you guys do not like exponents, negative exponents. So let's fix that as well. If we put a 1/2 in the numerator into the denominator, it will become 2. So our answer here, we will have 3x plus 5 over 2 times x plus 3 to the 1/2. Okay, and hopefully you're saying, Mr. Jones, could we do something about that 1/2 exponent? Yes, you could. You don't have to, but if you want it to be more proper, you would have 2 and then the square root of x plus 3. Because remember, anything to the exponent 1 over 2 is saying that it is the square root. Okay, and if you're saying, Mr. Jones, I don't like the square root in the denominator, that is understandable, but that is okay for this. If you leave a square root in the denominator for derivatives, I am okay with that. Okay. How do we feel about that factoring with the exponents? Are you guys really good with that? And it's just me?
A little confusing, but I think I got it. Or the
I know,
general
like the
idea.
first time that I looked at it, I'm just like, how does that make sense? But then it is actually what really helped me kind of make sense about the factoring and subtracting the exponents is just like putting it back in, right? Because when you multiply that factor back in, you're adding the exponents. So it's just like you're just subtracting them when you're taking it out of it, right? The more practice you get with this, the easier it will be, of course. All right. So we are back to the quotient rule, and we're combining the quotient rule with the chain rule here. Okay, so as always, let's identify our u and our v. So our u is going to be the numerator, v will be the denominator. So u is equal to 3 minus x. V is equal to, I'm actually going to write that one a little bit closer. V is equal to x squared minus 2x to the exponent 1 over 2. Okay, so take the derivative of both of these. So u prime is going to equal -1. And v prime is going to equal 1 over 2 bracket x squared minus 2x. 1 over 2 subtract 1 will be -1 over 2. And then we're going to multiply that by the derivative of what is inside the bracket. So that's going to be 2x minus 2. Okay, so we can simplify this v prime like we have been doing. So let's put our whole numbers out front. So we have 1 over 2. We can also factor out a 2 from that second term. So then we will have, so if we factored 2 from the 2x minus 2, we'll have x minus 1. And then we will still have the x squared minus 2x to the exponent -1 over 2 there. If we multiply these coefficients out front, 1 over 2 multiplied by 2 is just equal to 1. So we can get rid of that. There is our v prime. Okay, so now that we have our v prime and a u prime, we can solve for y prime. So the quotient rule, v times u prime minus u times v prime over v squared. So v is x squared minus 2x to the exponent 1 over 2 multiplied by u prime, which is -1. minus u, which is 3 minus x, multiplied by the derivative of v, which is x minus 1. Sorry, I got to go a little sideways here. X squared minus 2x. Divided by v squared. Okay. So we don't really have any coefficients to pull out front other than that -1. But now we need to ask ourselves, what is our GCF? And remember, lowest exponent and fractional coefficients. This one we don't have any fractional coefficients, but that was just a friendly reminder. Okay. So I see that x squared minus 2x is common in both. Okay, and remember we want to take out the lowest exponent as well. And to make our lives a little bit easier, because we have that -1 in there, and we're also subtracting, of course, because the quotient rule, I'm just going to factor out a negative. So I'll just show you. So I'm negative x squared minus 2x to the -1/2 is what I'm factoring out. Okay, so if I do this, if I take that out of the first term, I will be left with x squared minus 2x to the 1, right? Because if I'm subtracting a -1/2 exponent from this exponent right here, which used to be positive, that will make that a 1 exponent on there, okay? Because I factored out the negative, this negative here again will become positive. And now we will be left with our 3 minus x and our x minus 1. Okay, for our denominator, x squared minus 2x to the x squared minus 2x to the power of 1/2. If we multiplied that, like if we squared that, because we're just adding the exponents, we will just get x squared minus 2x. Right, because we multiply that by itself, we're just adding the exponents. Okay. So where are we now? We have okay, so y prime is equal to x squared minus 2x. This guy here, because it is a negative exponent, I'm going to put this in the denominator to make our lives a little bit easier. Okay, so this will look like x squared minus 2x. And our negative is still up there. And if we distribute this into here, and there, we will get plus 3x minus 3 minus x squared plus x. divided by this coefficient that we just put underneath. So x squared minus 2x to the 1 over 2. And the other term we have is the x squared minus 2x, of course, to the 1. Okay, we can clean this up a little bit. So we have a negative 2x, positive 3x. We got a negative x squared, and we have another positive x and a coefficient in there. So we're still going to have our negative out front. X squared minus x squared, those will cancel. We have negative 2x and positive 4x. So that will leave us with 2x. And then, of course, we still have that minus 3 there. And that will be over. So our denominator here, x squared minus 2x multiplied by x squared minus 2x. We can just add up those exponents. So 1/2 added to 1 whole is 3 over 2. And at this point, hopefully you're saying, Mr. Jones, we have 2 x's here. Could we simplify that? Of course we could. Okay, so I'm just going to move over to the right here. I'm losing a little bit of space on the iPad here. But yeah, so we have our negative 2x minus 3 still on the top. And on the bottom, we can factor out an x. So that will give us x minus 2. Exponent 3 over 2. We can distribute that throughout the lower bracket if you wanted to. Not necessary. I'm okay if you leave it like this as your answer. Okay. So that is the last question for today. So I hope this was helpful. If you need any help, please just ask.